today we are focusing on a free response question. Again, I was talking about how this chapter is so important because there's so many free response questions that can be asked from it. I think 3 out of the 6 free response questions come from this chapter. Okay, so it's really important. And this one right here is one of the ones that we could see. Okay, so find the values of g of 3. We kind of did this last chapter a little bit, so it shouldn't be too bad. So if I'm doing part A, the idea is simple. G is this guy. If I'm finding g of 3, what am I going to do with that 3? Plug it in for x. So it says I'm integrating from 1 to 3 of f of t dt. So if I'm integrating from 1 to 3, I'm integrating this thing. What am I finding? Area under the curve. The area under this curve right here, it is 2 across. It's up 4. So my area is 4. Boom, done. That's 4. If I do the second one, it's g of negative 2. So g of negative 2, I'm integrating. I'm starting at 1, and I'm going to negative 2. Okay, 1 to negative 2 of f of t dt. What do we notice about this one? Bounds are backwards. So I'm going to do it a different way. I've taught it differently earlier today, but I think it kind of screwed us up. So let's do it this way. You're starting here, and I'm working this way. What is my answer going to be as I get to 0? But I'm going backwards and left. So is it going to be 1 or negative 1? It would be a positive 1. And then I'm going backwards and left some more. So we could say it'd then be plus whatever this is. We got a circle. So it'd be pi r squared. What would my radius of this circle be? 2. 2 squared is 4. But I don't want all of that. I want to cut it into a fourth because it's a quarter of a circle. And so this is pi. It is 1 plus pi. If that is confusing to you, I went back and left, so it was positive. If that was weird, you could have flipped the bounds and said it was from negative 2 to 1, f of t dt. But there's an example that we do later that it makes more sense to actually kind of work that way. So just keep that in mind. All right, part B. Part B asked me to find g prime of negative 5. And this is the really important thing today. Okay, they're asking me about g, but they didn't give me g. They gave me f. Okay. Instead, what they did was give me a connection to build g and f together. F, when I take the antiderivative of it, gets me g. So if I have f, if I go back a step, it tells me g. So what else could I call this graph of f? G prime. Okay, G prime. If this was on your paper, you should write f equals g prime, and you should circle it and underline it and highlight it or whatever else you need to do. That way you don't forget. Okay, because that's going to be the key to unlocking this mystery. I know that this is a g prime graph. If you've written that down, then the next question is really easy. What is g prime at negative 5 going to be? Here's negative 5. Show me with your fingers. What do you think g prime at negative 5 is going to be? It's negative 4. Well, why is g prime at 5 negative 4? Yeah, you just look at the value. It's all about the value. Boom, right here, I'm down at 1, 2, 3. Oh, yeah, I'm at 4. It's just finding the value because it is a g prime graph. If you want to know what g prime is, you look at the graph. You write it down. That goes into my next one, g double prime at negative 3. So negative 3 would be like right here. Show me with your fingers. What do you think g double prime at negative 3 is going to be? Lillian, why do you think it's going to be 4/3 here? Perfect. This is g prime. So if she wants to talk about g double prime, she's talking about the slope. To get from there to there, she's got to go up 1, 2, 3, 4 over 1, 2, 3. It's up 4 over 3. Rise over run. Okay. Yesterday we had a rise over run question on our test. I'd say about like 6 out of my 60 kids put run over rise. Make sure you put rise over run as you do that. My answer is 4/3. Make sense there? We're going to build that today. All we're working with today are free response questions that are based off of graphs, just like that. We're going to be experts at it. All right, here we go. Today we are doing these questions. We are basing them off of free response questions. We were really good at this first semester. If I gave you a graph and asked you to find where's g increasing or decreasing or concave up, concave down, we were really good at that. We're just adding a layer today and be able to talk about integrals as well. All right, the graph of f consists of a semicircle and 2 line segments. On this interval, g of x is equal to that. They are asking you to find g of 0 and g of 6. Go ahead and try to do that real quick. Let's look. We are finding g. So g of 0 is super easy because it just told me what g is. G is equal to that. So all I had to do is plug in 0 for x. Natalie, what did you find for g of 0? Negative pi, because she's starting here at 2. Remember, 2 is her starting spot, and then she worked backwards. So from 2 to 0 right here, it's pi, but since she went backwards, it's negative. Negative pi is my answer. Show me with your fingers what you get for g of 6. G of 6 is going to get you 4, because you're going all the way to here. You've got 4. You add 2, you get to 6, but then you go down, so it's below. It's negative 2. You get 4 for your answer. Those are all pretty easy. Okay, the next one, g prime. This is a graph of f. What else could I call this graph? This is a g prime graph because the antiderivative of f is g. So this graph right here is also g prime. Write that on your graph. Put a circle around it. Make sure you know that this is a g prime graph. Go ahead and answer C, D, E, F, and G based off of that. G prime at 0. Show me with your fingers. What do you think g prime at 0 is? Rachel, why do you think it's 2? Yep. It's the point. You're just looking at the point. It is a g prime graph, so the value is 2. Perfect. G prime at 4. Show me with your fingers. What is g prime at 4? Same reasoning. I'm looking here at 4. The y value is 4. It is a g prime graph, so I'm just looking at the graph. G double prime at 2. Show me with your fingers. What is g double prime at 2? Sea turtles. What are we looking for on this graph at 2 to talk about g double prime? This is a g prime graph. So what do I need to know there to talk about its derivative? The slope. What is the slope at that spot? Not there. It is a corner. It is a cusp. It is D and E. Okay, we don't like sharp corners when we're finding that. G double prime at 3. So now we're looking at about here. What's that slope going to be? That one is 2. Rise over run. We go up 4 over 2. So if I'm up 4 over 2, my rise and run is 2. For letter G, I'm looking for G double prime right there. I'm looking at the slope right there. It's going to be negative 4. Questions on how I found any of those? Now we get into the free response questions. Okay. Find the interval where G is increasing. We are answering, this is super important. We are answering a question about G, but the graph was F. The first thing you have to do on a question like this is establish the connection. If you don't write this, you don't get any points for anything on this paper. Okay. You have to say that G, since we're talking about G, that is the same thing as F. I'm sorry, I lied to you. G prime is equal to F, or F is equal to G prime. I wrote that in a weird way. F is equal to G prime. That's what's true. It's what we wrote on our graph. F is equal to G prime. Once we've established that connection, now this problem became easier because now we can just go back to everything we learned first semester. They are asking me where G is increasing. Well, we did that all the time first semester. We said things like G is increasing because G prime is what? G prime is positive. Okay, that's what I'm looking for. So now that I've established that, again, I'm writing the answer before I find it on my graph because it makes my brain work better. Okay, I'm looking at that graph and now I'm saying, where is that graph positive? Well, from negative 2 until 5. G prime is positive. That means G is increasing. Does that make sense on H? On I, same idea. We're finding the interval where G is concave up. Well, I don't know about G. What I know is F. And so the first thing I have to do is say F is equal to G prime. I need to establish that connection. Once I've said that, now I can say, all right, well, G is concave up because G prime is blank. That's my justification. I am writing the justification before I even do the problem. Finish that with your neighbor. Braden, G is concave up because G prime is what? What is the answer? Answers that. G prime is increasing. Wonderful. Okay, because we are trying to go up a derivative, so we want to look at its slope. So we're thinking that it has to have positive slope to be concave up, because concave up is really talking about the second derivative. G prime is increasing, so this is a graph of G prime. All I'm doing is looking at that graph and deciding when I'm increasing. That's from negative 2 to 0 and from 2 till 4. I'm going up. It's increasing. I'm increasing. Those are the two spots where I'm increasing on that graph. Am I good to there? Let's do this one together. Find the points of inflection for G. It didn't ask for a justification, but we could easily do one. We would start off by saying F is equal to G prime. G has POI because G prime does what? What has to be true about G prime in order for you to have a point of inflection? The slope is equal to Z. That's part of it. The slope changes signs from positive to negative or negative to positive. Or we could say G prime has relative extrema. We used that before, but it's been a minute. Relative extrema. Remember, the slope is changing signs from positive to negative or negative to positive. Show me with your fingers how many points of inflection does this graph have? This guy's got 3. Every place that's a max or a min. And so it doesn't matter that like the slope is 0 there. But the slope is undefined there. It doesn't matter. That's a minimum. It's changing. It's a minimum because the slope is changing signs from negative to positive. And right there is 1 as well. So my answer are 0, 2, and 4. Everybody good there? Yes, ma'am. So it has to be no. So when they won't do that, so a point of inflection is going to be a one moment in time thing. It's not going to be over an interval. We wouldn't refer to that as a point of inflection. It's a good question, though. Let's look at letter K. So letter K is one of those ones where you guys start looking out on your test and all of a sudden you quit. Okay? Don't let this be hard. It says write the equation of the tangent line for G at x equals 0. As soon as you read that, what should you put? Y minus equals x minus. Right? Write the equation of a tangent line. Boom, there's my tangent line. What is something that I know about that tangent line? X is 0. And don't forget, the thing that messes everybody else up is this idea. This is a tangent line for G. It's a G tangent line. And so what do I need to write an equation of a line? I need a point. I need a slope. So my point, how am I going to find the point that goes with this? You look at my graph. What am I looking for on this graph, though? I want to find G of what? It's G of 0. So I'm looking at the graph, but that's what we found right here, right? That's an ordered pair. I want to write the equation about G. And so when x is 0, what's your y going to be for G? Negative pi. So this is going to be y minus negative pi, so y plus pi. Same idea here. What is going to go in for my slope? I want to know the slope of G at 0. It's 2. Because this right, we wrote it down already. We wrote it down, G prime at 0. We found the slope of G at 0. That's exactly what we wanted. Don't forget what you're doing. Okay, we wanted G at 0. That was negative pi. But we also wanted G prime at 0. That was 2. We put that in there. We're good. Okay, one more here. Find the absolute maximum value of G on this interval. Absolute maximum value. We've done this before, and we're going to do it again in this chapter. Justify. This is the one time in calculus. When it says justify, it doesn't mean you use words. How do we justify an absolute maximum value? This is a table question. We are finding the absolute maximum value of G. Okay, so I need to know some X values, and I need to know the value of G. I want to know when G is at its biggest. So the way we do this is we justify it with a table. Okay, remember what you're doing. You're finding maximum values. Well, where can maximums happen? Maximums can happen at 2 different types of places. Maximums happen at endpoints and critical points. So endpoints are easy. That's -2 and 6. What about critical points here? Looking at that graph. Remember, this is a graph of F, which is really G prime. It would be 2 and 2 and 5. Yeah, that's a bad 5, but it's 5. Remember what this is. It's G prime, right? Critical points are when the derivative, this is G prime, when the derivative is 0 or undefined. Okay, so when is it? Right here and right there. Is 2 going to be a maximum? No. Why not? It doesn't change signs. We said you got to change signs in order for that to work. It doesn't do that. Okay, so the only real option is 5 going to be a maximum? Yeah, it changes from positive to negative. We got to see if it's the absolute maximum, but yeah, we're thinking that's probably our spot. We can kind of use our brain there and figure that out. Remember what it said G was? G of x is equal to 2 to x f of t dt. So we found my spots. Now all we got to do is plug them in. So I want to find G of negative 2. What is G at negative 2 going to be? The area under the curve from 2 to negative 2. Negative 2 pi, because 1, 2 pi, negative 2 pi. What is G at 2 going to be? So I'm integrating from 2 to 2. 0. Because that didn't go anywhere. From 2 to 5, we said that this was 4 and this was 2. So G at 5 is going to be 6. And G of 6 is going to be 4. Now think about that. We're done. But we have to answer the question. Find the absolute maximum value. Show me with your fingers. What is the absolute maximum value of G of x? The answer is 6. Not 5, but 6. Because why? That's the value. This is where it happens. Where does it happen? At x is equal to 5. But what is the value? The maximum value is 6. Make sense on what we did there? It's a little weird. We're going to do it a lot. So if you're not an expert yet, you'll become better at it as we go. Let's go to the back side. I got to keep going here. This was a free response question. I stole everything on this question from 2016 AP exam. All I did is I copied and pasted. Okay, so now we're to that point where we can do everything. We can do all parts. I didn't have to modify at all. This is 9 points on the AP exam. Okay, if you score 40 points, you pass. We got to just be okay here. This is going to get me 9 out of 108 points. Let's see what we got. This is a graph. It tells me right here that G of x is equal to the integral of f of t. So it says this is the graph of f. What else should I label on this graph? This is a G prime graph. I'm going to write it. F equals G prime. I'm going to circle it and make sure my brain knows what it's saying. You have to write it one time at least. Okay, if you look over here, this is the answer key. It says right here, you get 1 point on this test if you just write G prime equals F, either in A, B, C, or D. You just have to write it one time. Now, I'm going to do it every time, so you don't forget it. But you have to label it at least one time. If you do, you score a point. You only got to score 40. Just writing G equals F prime scores you 1. Or F equals G prime, sorry. Does G have a relative maximum, minimum, or neither at x is equal to 10? Does G have a relative max, min, or neither at 10? Talk with your neighbor for a second. Come up with an answer. Thumbs up for maximum. Thumbs down for minimum. Thumbs in the middle for neither. Max, min, neither. We're saying neither. So neither. I'm going to go ahead and say F equals G prime. I need to establish that connection because this is a question about G. But then we have to justify. So we're saying neither. Why? Anybody have a good reason as to why it is not a maximum right here at 10 or minimum? G prime does not change signs. In order for it to be a maximum or minimum, the derivative has to change signs. It doesn't, so it's not. That's it. Okay, it goes from negative to more negative again. We're done. This is a G prime graph. That's it. Does the graph of G have a point of inflection at 4? Talk with your neighbor and then justify. Thumbs up for yes, thumbs down for no. Do we have a point of inflection? We're saying yes, yes. G has a POI at x is equal to 4 because G prime, because that's what it is. But again, I had to make this connection. F equals G prime. Anybody have a reason? Because G prime does what here? G prime has relative extrema. That's just memorizing the chart. We know that if G prime has relative extrema, like it does right there, there's a maximum, then it is going to be a point of inflection. Done. Letter C says find the absolute minimum value and maximum value of G on this interval, and then justify. Absolute minimum or maximum value. And we're trying to justify it. How do you justify an absolute maximum or absolute minimum value? A table. You've got X, you've got G. I will help you out here. This is 4, this is 8, this is 8, this is 8, this is 4. Go ahead and try to figure out what you need. And mins, where could they happen? What points am I checking here? Endpoints, critical points. So endpoints, those are easy. -4 and 12. Critical points, what other numbers do I need here? -2 and 6. Those are the only two other points where G prime changes signs. So they're really the only other values I need. Then we just got to do it. Again, remember that my integral is starting at 2 and working my way out. That's what G of X is equal to. So make sure you don't forget that. I'm starting here at 2. So if I go to -2, what's my area going to be if I go to -2? It is -8. If I go to -4, now I'm going left and below, so now it's going to be -4. If I go to 6, it's going to be +8. And if I go to 12, it's going to be -4. What is the absolute max value? 8, because it's just looking for the biggest number. That's the max. What is the absolute minimum value? -8, because it's that guy right there. That's the min. That's all you're looking at. Here's the justification. You can score 3 points or 4 points on this one alone. Okay? Consider the endpoints. We did it. Consider the critical points. We did it. Answers with justifications. Well, this is my justification, is that table right there with the answers. Okay? That's all you had to do. And then this last one. This last one's a little bit tricky. Find all of the intervals where G of X is less than or equal to 0. So let's look at that together here. Think about what we're doing. G of X is going to be from here to here. When is it less than or equal to 0? So we got to go the whole span of this thing. Be careful here. We're starting at 2. If I work this way, right now, is my area negative? Is G of X negative if I go this way? Yes. Is it negative still? Yes. Is it negative still? Yes. What is my value right here at -2? It would be -8, right? It's the area under the curve as I go this way. Is my value negative when I get to -4? Yes, because it was -8, and then I went back and left. So it's like I added 4 to it. So now I'm at -4. That's still negative, right? We just wrote it down right here that at -4, my value is -4. So I am negative on the interval all the way from 2. I'm sorry, I did that wrong, incorrectly. -4 to 2. During that whole time period, I am negative. I have negative area that whole time. But the best way to do it is to start at 2 and work backwards. It's a little strange, but that's what we're doing. Okay, let's work to the right now. As I work to the right, is my area under the curve positive or negative? Positive. What is it when I get to the end of this thing? It's 8, so we're definitely still positive. Right now, am I still positive? Yeah? Tell me when I switch. What's my area right now? Now I'm at 0 because I had a +8 and a -8. Now I'm negative because I start going below and it's going to keep working below. And so my other interval on that thing is from 10 to 12. A strange question, but now all of a sudden we scored 2 more points. We just scored 9 on that question alone. You only got to score 40. We already scored 9 and we haven't looked at any of the rest of the test. Does that make sense how that works?